It's the last homework video, and I bring you a special treat, October. She's not very happy I started talking, but we'll see if she stays there. Anyway, we're going to do some problems from Unit 9, starting with number 1. So this study, there's a study that's collecting, goodness, October, you're very distracting. There's a study that's collecting information on the following variables from people who drive: blood alcohol level, reaction time, and we want to create a scatter plot illustrating the connection between these two variables. Go to the other cat. He's kind of hiding. So what variable would you use as the explanatory variable? And which one would you use as the response variable? Explanatory a lot of time is the independent. It's the X. It's the thing that we're looking at. What are the effects of this variable? Response variable is that Y, that dependent variable a lot of times, the result. So in this one, it makes sense that the explanatory would be the blood alcohol level. We're curious on how this affects or how this might explain reaction time. And as blood alcohol content level goes up, do we think reaction time will go up or go down? And be careful, because we think, okay, the more drunk you are, the worse your reaction time is. But that means your reaction time increases. It takes longer to react. So increase in alcohol is increase in reaction time, even though we think it means worse. So we're going to say a positive correlation on this one. All right. Let's look at number 3 now. Which of the following is false? Well, let's look at each of these statements and kind of evaluate how true or not they are. If the correlation between variables is close to 0.01, there's a very weak linear relation. That's pushing it. There's almost no relationship here. Second one, correlation coefficient and the slope always have the same side. Yeah, if the R value is positive, the slope is positive, and so on. If the correlation coefficient is 1, then the slope must be 1 as well. Oh, that's definitely wrong. If the correlation coefficient's 1, that just means we have perfect correlation. But it doesn't mean that the slope has to be at a 45-degree angle. You could have perfect correlation that looks like this, perfect correlation that looks like this. That one's definitely wrong. This one's like half right. The bottom one, correlation measures the strength of linear association between two numerical variables. Yep. There we go. Number 5. Match each scatter plot below with one of the 4 specified correlations. I love these problems. So what do we think about this one? Before we even look at the numbers, what do we think about this one? It looks barely correlated at all. But if anything, I don't know, maybe there's a negative correlation. I don't know. It's pretty garbage. Let's skip that one. The second one, I mean, I pretty much am pretty sure I know the answer, but I'm trying to show you the steps that you should do. Okay. This next one, okay, there's positive correlation, looks like, but again, not very strong. So we're going to choose C on this one. Positive correlation, not very strong. Okay, this is very strong. Negative correlation. So you should pick a negative number close to -1. There we go. That's definitely D. And this last one is positive correlation. Stronger than the other one, but still not super strong. 0.66. It's going to be our A. So just as expected, that leaves this one with our B. It's negative correlation, but it's pretty weak. If you try to draw the best line that goes through, and remember the best fit line is not the line that goes through the most amount of points. So you're not drawing a line right here. That would be a positive slope. The best fit line is the line that minimizes the square of the residuals. It's the line that basically makes the least amount of error. Okay, so it is going to be negative here on this one. The ones though that like this that are super weak, I don't care as much about that because these ones are they're a little hard to see sometimes. Which is why I wanted to do this problem. Let's do number 12 now. Interpreting. Good. I love some interpretation questions. Can you translate the math into English? Lena invested some money into an account. The balance in the account is given by this equation, where T is the number of years since the initial investment was made. So this account is losing money. It has a negative slope. Sorry. I'm jumping the gun. B is the account balance. The equation tells us that Lena started with how much money? Well, the start is when no years have gone by. The start is when t equals 0. Let's write that down. All right. This equation is B equals 5950 minus 40t. And the start is really when t equals 0, when no time has passed. So when t equals 0, what's B? Well, it's 5950 minus 40 times 0. Oh, it's just the y-intercept. And a lot of times we can think of the y-intercept, that 5950 is the y-intercept. A lot of times we can think of the y-intercept as the start. That's not perfectly true all the time, but most of the time, that's one way that we can think about y-intercepts. And is B the balance? Yes, it's not, and there's no units of like thousands or millions. So it's just going to be $59.50. The dollar sign's already included, so we're just going to write 59.50. That account balance is increasing or decreasing? Well, look at the slope. This is our slope, right? And this is our y-intercept. The slope is negative, all right? It's negative 40t. This account, if we made a little graph, right, starts up here, and then it's losing $40 every month. Every year, sorry, is it every year or every month? T is the number of years. So yeah, every year we're losing $40 in this account. Okay, well that's what we're supposed to answer. At a rate of 40, what are the units? Sorry, I said dollars per month. Dollars per year. The slope, remember slope is rise over run? So the units, oh, I just wrote that underneath my cat. You can't see that. The slope is rise over run. That's a slope. So the units of the slope, the units of this 40 are also rise over run. If this is dollars and this is years, well then the slope is dollars per year. That'll always be true about lines. So there we go. Nailed it. See, I say we nailed it before I even checked. That's the level of confidence I have. Let's do another one. 2 more questions. I was trying to see if October did come back in, but she's hiding. I don't know where she went to. Many people believe that there's a negative relationship between the amount of time students play video games each week and their GPA. I was probably an outlier if we look at this graph. Played a lot of video games in college. All right, so I am assuming that it doesn't tell us here, but I'm assuming this is the hours of video games played each week, and this is going to be their GPA. Find the correlation coefficient. Well, okay. Let's copy and paste this data into GeoGebra. Oh, nice. It actually copy and pasted correctly. We're going to hit 2 variable analysis. Make sure that it was input correct. Did we have a point like 10 and then a half? Yep, we did. Or 1.5. Oh, it doesn't start at 0 over here. Good thing to check. All right, yep, it looks like it's working correctly. Did we have a point 0, 3 point something? Hey, we did. Great. So nice to make sure that GeoGebra is interpreting what we're telling it to do correctly. So let's make a linear regression model. And let's look at some statistics and answer some questions. All right, first question, correlation coefficient, negative 0.8856, oof. round to 4 decimal places. That is strong negative correlation. But correlation does not equal causation, so maybe you can still play video games. Write the regression equation below, rounding to 4 decimal places. We're just going to copy this down here. Negative 0.1839. X plus 3.443. Using the data, predict a student's GPA if they play video games for 15 hours a week. Oof. Wait a minute. That's extrapolating data, right? Linear regression lines are really only useful for interpolating, but our data really only goes from 0 hours to 10 hours. So 15 hours, I'm already a little suspicious, but I'm going to do what it wants. For 15 hours, well, we just use this equation and type in 15. A GPA of 0.6845. But we want to round to 2 decimal places. Yeah, that's gonna be crap. Anyway, what percentage of variations in GPA can be explained by the number of hours students play video games each week? It's asking for your R² variable, or R² parameter, 78.42%. Make sure to round correctly, follow the instructions. It wants it as a percent. There we go. So most of the data, 78%, can be explained. Most of that variation in GPA can be explained by how much video games you play. Again, this is not saying playing video games causes you to do worse in school, but it's looking at the correlation of those 2 variables. It's one of the points of this unit. Correlation is not the same as causation. We could do some experiments. Some controlled experiments. But here we're just practicing correlation stuff. Last problem, let's do number 18. And then we'll see if we can find October. Oh, I found her. She's at my front window. Isaac's investigating how long his phone battery lasts in hours at various brightness levels on a scale of 0 to 100. He graphed his data below. What's the residual for this point? Well, residual is just the distance between the point and the regression line. So the point is right here, 72,5. How far is that from the regression line? Well, we need to find the regression line. Let's copy this data down somewhere. All right, scoot over. And then select only the data we want to variable analysis. Was there a point like 95,1? Hey, there was. Does this look like the graph in the homework? Yes, it does. These are all good things. So this is our regression model down here. Y equals negative 0.0618 x plus 8.1971. So we need the predicted amount at that x coordinate. What's the y value at that x coordinate? So we plug in 72 into the regression line. When I copy and pasted it, it did something a little weird with rounding. Times 72. Let's make this, clean this up. And it doesn't like the spaces. And it doesn't like something else. I could just 3.7475. So our regression line should be about 3.4 here. Yeah, sure. Looks kind of really close to 4 to me. Did we copy this down right? Yeah, we did. Okay. And how far is that from the actual value of 5? Well, that's 5 is above it. So we're going to take 5 and minus that. We're going to 1.2525. The actual was about 1.25 hours above what was predicted. So the life was over an hour more than what we predicted based on this. All right, and there you have it. Shed a tear, your last homework video for this class. I guess you could go back and rewatch some old ones if you really wanted to. Say goodbye to Theodore and have a good one. Bye-bye.